Hello everyone and welcome to this video. Today we are going to be learning about we're still going to be learning about manipulating and comparing arrays like we did in the previous video, but instead of arithmetic we are going to be learning about aggregation. Okay, so as I told you, what are we going to learn? We're going to learn about manipulating comparing arrays and about aggregation. Now, now I will tell you what aggregation is when we start learning. But just a reminder, in the previous video, we learnt about arithmetic. Okay, so we learnt about arithmetic. We learnt about how to add different arrays together, subtract times, which was represented by an asterisk. This is the usual Python symbol. Divide, use modulo, and also find the power. Okay, so without wasting any more time, let's launch our Jupyter notebook. Okay, so what we want to do is we want to click search and search up Anaconda prompt or terminal if you are in Mac OS X or Linux, but I'm searching up Anaconda prompt because I'm in Windows. Okay, so here it is. I'll just zoom in so you guys can see. Now, basically, if you have not set up your environment for machine learning yet, please do so before you start this video, before you type in any of these commands actually, because otherwise it will throw you an error and it won't even make sense. Okay, so here we want to activate our environment. So conda activate. My environment is in users, desktop. Okay, I tell you, I wrote desktop wrong. Desktop folders, ML, not ML library, sorry. ML course, practice project, and then okay, so it's saying it's not a conda environment. So what we have to do is, as you saw, there were like speech marks coming. So you need to search up Anaconda prompt or terminal again. If that happens, in my case, that actually did happen. So again, conda activate users. Slash ML course practice. Okay, I spelled ML course wrong, didn't I? So ML course, practice project, and enter, and our base would have turned into this. So now we need to type in Jupyter notebook to launch it, enter, and it should now launch. So let's wait for it to launch. Okay, so what it's done is it has launched and it will give you the home page. Okay, so what you need to do is you need to use this path you need to use it from desktop and just follow this path and go to where your normal practice notebook is. So that is what I'm going to do. See you when I have done that. Okay, so here is where we left off last time. Hopefully you guys got your Jupyter notebook up and running. I've got mine. And as I told you at the start, we learned about arithmetic methods, okay? So today, what are we going to learn about? Okay, so we are going to learn. Okay, wait. So we're going to learn about scan enter for markdown, aggregation. Okay, so yeah, that is what we are going to learn about. You might want to actually search what that actually means, because sometimes because even when I started I didn't even know what aggregation was. Okay, so what we're going to do is we're going to search that up by typing in, I'm just going to define aggregation. Hopefully I spelled that correctly. Okay, so I'll just zoom in. So it is the formation of a number of things into a cluster. Hmm. Uh, it's a little bit what we're doing. But actually, what I mean by aggregation today. So if we just write this down. So by aggregation. So aggregation. So what I mean by this is performing the same operation on a number of things. So what I mean is just performing the same operation on probably like a collection. So maybe a collection of arrays, you just perform the same thing. So first I'm just going to demonstrate to you with a Python list first. So if you don't know what a Python list is, go ahead and watch the video. I'll just put the link about right over here. Okay, so right here I'll just put the link. So basically, what we want, so how do you create a Python list? So I'm going to make a variable called L. So I'm going to say L is equal to nice simple list 1, 2, 3. Okay, L is equal to 1, 2, 3. We can check the type of sorry, there we go, and it is a Python list. So here I'm just going to show you an example of aggregation. So we can do the sum of L, and basically here we're performing the same so actually this is an aggregation, sorry, I just mixed up. So here we just performed a sum. Okay, so now let's try this on a NumPy array. A1, so we had A1 earlier. Whoops, it's saying A1 is not defined. Okay, why is that? Sometimes that happens. So usually sometimes your kernel just doesn't start properly. So what you need to do is you need to restart your kernel. So you just click this, restart, and after that you'll just have to run everything again. So that is exactly what I'm gonna do. You can just hold shift and enter for all of the cells, and hopefully it should come. If it doesn't, you can just run it all over again. It won't take too long, so don't be bothered by this. Okay, so I'm just gonna run that. There we go. So this time my array actually ran. It ran how I wanted it to. So we can check the type of A1, and it'll give us an ND array, okay, because that is the correct type. So let's try the sum and see if it works. Oh, so that's actually working. 1 plus 2 is 3, and then 3 plus 3 is 6. Oh, so what's the point of just having a NumPy method? So basically, if there is also a NumPy method called np.sum that only works for arrays, okay? So what's the point of having a NumPy method and a Python method when they both do the same things? So basically, NumPy methods, so a good practice is to, let's just write this in Markdown, is to use Python's methods for so Python methods such as the sum method. So sum on Python data types. So this is true. Just use them on Python data types. I spelled that wrong, didn't I? So use them on Python data types, and also use NumPy's methods on NumPy's data types. Okay, so this is the rule you should stick to, then it will be much easier. So one method of NumPy, as I just saw before, is np.sum. Okay, so what I'm going to do is I'm just going to put this in code by putting two of these symbols here. Okay, so now we've got this note, we can reference to it when we like. So actually, I'm not going to put this just in code. I'm going to put this in bold actually, so it's better. Yeah, there we go. So I only use like Python's method on Python data types and NumPy's methods on NumPy's data types. Now, I will actually demonstrate to you why. So what I'm going to do is I'm going to create a massive array just to show the power of NumPy's methods on NumPy's data types. So what we're going to do is we're going to create a massive array just for demonstration. So I'm going to say massive array is equal to np.random.random. Shift tab if you're not sure what it does. Returns random floats in the half open interval 0.0 to 1.1 basically. Okay, so we want a size of 100,000, I guess. Yeah. And let's check the massive array size just to see if it's correct or not. Massive array dot size. Okay, so there we go. We've got the size 100,000. So let's look at the first 100 elements. So massive array, let's say the first 100. Okay, so that is actually really big right there, you can see. So actually, let's just minimize that to 10. So we have more space. There we go. So we've got our first 10 elements. Now we're going to use the time it module to demonstrate how fast it is. If you would like to know more about timer, I've got a video on that, so please watch that. Okay. So if you're in Jupyter Notebook, remember you need to type in. You need to use the time it magic methods, and you don't need to import timer if you're in Jupyter. Otherwise, if you're in another IDLE, what you can do is you can watch the video that I just told you about before. That one has how to do it for normal IDLE users. So here I'm going to use a Jupyter method. So what we do, pass in the time it magic method, and then we want to pass in the code. So let's find out the sum. Let's just use a normal Python one, and we're gonna pass in massive array. And we also want to use time it on the np.sum as well. And we're gonna pass in massive array here. If we run this, it could come a little bit slower. It could come slow or fast depending on your computer speed. So let's just wait for the second bit to come to, so we can compare it. Okay, so both of them have come now. So as you can see, this kind of looks really confusing. So what has it done? It is saying there it has done 32.7 milliseconds plus or minus 1.65 milliseconds per loop. Okay, and it's done. So basically, it's 1.65 milliseconds per loop. And here it says 111 microseconds, so this stands for microseconds, plus or minus 5.81 microseconds per loop. So let's look at, let's say, microseconds and milliseconds. Okay. Oops, let's just actually not that. Just guys, oh my goodness. Let's just type in conversion from microseconds to milliseconds. Okay, so don't type that in, type this in. Okay, so it says 1 microsecond is equal to 0.001 millisecond. Okay, so let's look at 1.65 milliseconds. So 1.65 milliseconds. Okay, that's equal to 1,650 microseconds. Okay, and here it only took 5.81 microseconds. So clearly using a NumPy method on a NumPy array is way faster than using a Python method on a NumPy array. So please just if you want your output to be faster and more efficient, please just do this. Okay, don't use a Python method on NumPy array, otherwise it'll get pretty confusing. Okay, so let's learn a bit more about aggregation. So let's bring in another array, our trusty A2 array. It has 2 rows and 3 columns. So we can find the mean of A2 by doing np.mean. So remember, no Python method, just NumPy. np.mean, we pass in A2. Okay, 3.65, perfect. So basically what has the mean done? So if we find the np.sum, A2, it has added all of it together. So let's store this in a variable. Sum is equal to actually let's type in A2 sum is equal to np.sum of A2, and then A2 sum divided by 6 because there are 6 elements. Okay, so you're okay, so 3.65, 3.65. So basically these two cells, so this cell and this cell basically equal to this cell. Okay, so you can visualize it like this. Okay, so that is what it equals to. That you can also find the max, so np.max. Again, these are actual Python methods, but NumPy uses its own just to make sure your code is more efficient. So we can find the max of A2, and in this case it is 6.6 because 6.6 is the largest value. We can also find the minimum, np.min. Whoops, np.min A2 because otherwise it won't know what error. If we look at A2, the minimum value is 1.0 or 1. Okay, so you can also find the standard deviation. So np.std, and you can pass in A2. Okay, so once you've done that, that's the standard deviation. There's also the variance. So np.var, pass in A2. Okay, so you may be thinking, what the hell are variations and standard deviation? So in comments over here, what I'm going to do is I'm going to write it. So basically the variance is the measure of the average degree to which, did I spell that correctly? No, I didn't. To which each number is different to the mean. Okay? Okay, so that is what the variance is. And if you get a higher variance, so a higher variance is basically a wider range of numbers, and um, a lower variance is basically a lower range of numbers. Okay, so that is what variance is and what higher variance and lower variance is. And also the standard deviation is so the standard deviation is a measure of how spread out a group of numbers is from the mean. Okay, so that is what standard deviation is. And also the standard deviation is actually the square root of variance. Okay, so this is, I'm going to show you. So over here I'm going to write standard deviation. So you can reference it as the square root of the variance. Okay, so that's what you can reference it to as. So basically np dot square root is basically np the variance of A2. So the variance of the standard deviation of A2 is basically the square root of the variance of A2. Okay, so module NumPy has no, not variance, sorry. Okay, so if we look here, this is the same result for the standard deviation. Now, don't worry if you didn't understand. In the next video, I'll be covering standard deviation and variance, because this is actually a very important topic in NumPy. So in the next video, I'll cover that. And if you like this video, please like and subscribe. Otherwise, if you have any comments or doubts, please comment them in the comment section below. And if you have any, and I guess that's the end of this video. Bye.